Alright, we're getting ready for part 2 of the testing. This will be the destructive test. We know what velocities we're going to get at what pressures. So now we're going to actually put the handle on the bolt and fire it in the setup and see what happens, whether it breaks or bends the handle or the simulated breech. So I'm going to go ahead and remove the dummy weight from the front. This weight simulated the weight of the handle. And now I'm going to go ahead and install this into the gun and fire it. Now this time we won't be able to fire it across the chronograph. We've got the bolt handle installed. Moves back and forth. I'm going to bring it back and latch it. And it'll stay put until we fire. And then it'll slide forward and hit this. It'll hit the end of the groove at the velocity we already determined. And then we'll see what kind of damage we get. Okay, there you see the bolt handle sticking out the back. We're all latched, ready to go. We're going to try at 400 psi first. Going to go ahead and pump it up to 400. Alright, I got it pumped up to 400 psi. Alright, well that's encouraging. Happened. The handle's still on there. Go ahead and take it apart and we'll see what it looks like. Actually, I'm just going to unscrew the bolt handle. Bolt handle looks relatively straight. It's kind of hard to see with the camera. Handle doesn't appear to be wobbling, so I'd say it's probably straight. So I'm going to go ahead and reload it. That was at 400 psi, and maybe go up to about 700 this time. Let's see what happens. 700 psi. All right, again, nothing looks bad from a distance. That would have been 70 feet per second. The bolt would have been going 70 feet per second. By the way this slot is set up, when this, just before this hits, all the air can exhaust. Now, see a little bit of wobble means the handle was bent. Now the handle is a grade 5 bolt. And there's a little bit of a chamfer in the bolt itself so that you don't have a sharp edge to shear this off. I ran into that with some previous testing where I had nice sharp square corners and tight fits, and instead of bending it just sheared just like in a punch press. Alright, bent a little bit but not bad. It's good enough where we can take and run another test. Alright, we are set up for another shot, this time at 1000 psi. That would be the equivalent of the bolt launching rearward if you haven't locked it at 90 feet per second. All right, again, doesn't look terrible. Let's see how it unscrews. Bent pretty good. You can see it twisting there. Did not shear off. And you can still unscrew it by hand. So that means it's repairable. Bent, obviously. If this had been a hard bolt, like a grade 8 or something like that, it may have broken off instead of bent. can see it's got an offset, pretty good offset to it. The fact that the breech is aluminum takes a lot of the impact. That's a good thing. All right, we're pressurized to 1300 psi, which will be for 104 foot per second shot. You can see the handle is already damaged, bent backwards. The slot was elongated by 10 thousandths, 0.010 inches longer, and slightly puckered at the end. So let's see what happens now. This is 300 psi more pressure than last time. Okay, well, it was obvious what happened that time. The bolt handle sheared off and the bolt flew right out. So here's the sheared ends. There you go. So that was 104 feet per second that it took to shear that off, of the bolt traveling backward at 104 feet per second, which is 3 or 4 times as much as any factory gun will ever see. 1/4 inch bolt handle, grade 5 bolt, 1/4 28 threads. It did shear off, but it had been damaged other times. So that's what we've got now. Yeah, you can see it. See the end of the slot is kind of puckered up where the bolt handle hit it. And the slot itself is about 15 thousandths longer than it started out as. So even though I was only doing this at 1300 psi, it's because of the long travel in the slot, it simulates a shorter travel at a higher pressure. So anyway, it just shows you what can happen if you forget to lock the bolt. So don't forget to lock the bolt. This is another 1270 grain bolt and handle combination. This time the handle is a grade 8 bolt, 1350 psi. We'll see what happens. Looks good. Not in bad shape, but it did bend. No evidence of cracking or anything like that. For this next shot, we're going to use the same setup. The weight is going to be the same, 1270 grains. Travel, again, 1.9 inches. This time we've switched to a 5/16 grade 8 bolt to use as a handle, compared to the 1/4 inch grade 8 bolt, which is next to it. This is a 1270 grain bolt with the 5/16 grade 8 bolt handle. We've got it pumped up to 1400 psi. No apparent damage. We'll see. Bolt slides. It's a little tight, but it comes out. Bolt appears to be undamaged, I think. The handle part. The bolt looks to be good. The way it came in and out of the tube was okay. There is some puckering on the aluminum, though, from the impact.